Hi class, this is Mr. Somerville here with a follow-up on quadratic inequalities. I had some questions after those worksheets that you had done in the first few videos you watched, so I wanted to go through and just revisit that second worksheet you were given on solving quadratic inequalities. Well, technically it's the third one of this week. A lot of those ended up having boundary points that were fractions, and I know there was some confusion from students on that. So what I thought we would do today is just take a few of the problems from the worksheet and solve them together so that you can see that process and really be reminded of how factoring and the zero product property can work, because these were factorable although we were getting x-intercepts that were fractions. So let's jump right in. Let's look at number 1 to get us started. It had 18x squared plus 23x plus 5, and that was less than or equal to 0. Now the difference here, that 18 is probably throwing some of you off because traditionally that had been a 1 when we were doing the first worksheet. It doesn't really change how we factor though. So if you remember the structure of using the generic rectangle and the diamond problem to get us going, we can still fill those in. So we'll have 18x squared and 5 in our corners. When we multiply those, we'll get 90x squared, that goes in the top of our diamond, and then 23x will go on the bottom. So we're looking, okay, what multiplies to 90x squared and adds to 23? This problem was really set up nicely for us because 18 and 5 for sure multiply to 90, we already did that. They also happen to add to 23, so those are the two values that'll go with an x on the sides of our diamond problem. Now that we've done that, 18x and 5x go in our rectangle. That means that we'll pull out the greatest common factor, so I'll pull out 18x straight down that column and pull out x from this side. Here I can take out a 5, and here all I can take out is a 1. So now replacing this in the equation, I can use the equivalent factors of x plus 1 and 18x plus 5. This does say less than or equal to. Since we're really just getting boundary points right now, let's just treat it like it's an equals sign, because we're going to see, okay, what are those boundary points here? Two things multiply together to give us 0. That's the zero product property, meaning that x plus 1 must equal 0, or 18x plus 5 could be equal to 0. When we solve those, well, here I see that x would equal -1 if I subtract that. Here, if I subtract 5 and then divide by 18, I'll see that x is equal to -5 over 18. So those are our boundary points that we're going to put on a number line. If I draw my number line with a straight edge, I don't know why it's not writing. Let me try this without a straight edge. There we go. So looking at our number line, if we have 0 right here, well, here's the thing. We have to decide, okay, which is greater, -1 or -5/18? This is the first time we've really had fractions for boundary points. Well, since the absolute value of -5/18 is closer to 0 than the absolute value of -1, it'll be closer here as well. Let's call this -5 over 18, and then just to give us space to work, let's push -1 all the way out here. So now we know there are 3 different regions we could be in. We could be less than -1, we could be greater than -1 but less than -5/18, or we could be greater than -5/18. Those are the 3 different areas we need to test as we work through this. To do that, let's go to our original equation. Let me clean things up a little bit here. And really, we don't need the work for our boundary points anymore. We've already established what those are. So we go back to the original equation, and we try some values in those different regions. First, let's go greater than -5/18 because 0's right there, and that's an easy one to check. So if I do 18 times 0 squared plus 23 multiplied by 0 plus 5 is less than or equal to 0. Really, I did a lot of writing for nothing because those two cancel out, and we see 5 is less than or equal to 0. Well, that doesn't seem true, meaning we won't be shading in that region there. All right, let's go to less than -1 next. I'm kind of picking them in the order of how easy they are to test. So if we're going less than -1, we can pick any value we want. I'm going to pick -2. All right, so 18 multiplied by -2 all squared plus 23 multiplied by -2 plus 5. We're going to see if that's less than or equal to 0. All right, so if we square -2, we get +4. So 18 will be multiplied by +4. Oh. We'll add that with 23 times -2, which is -46, plus 5 is less than or equal to 0. So now 18 multiplied by 4 is 72. When we combine -46 and +5, we can just write that as -41. Really, at this point, hopefully you can see this is not going to be true because we're going to get a positive number. But just to finish it off, we'll see +31 is less than or equal to 0. Again, not true. So right now, we pretty much know that it has to be in that center region, but surprises happen once in a while, so let's make sure that's the case. Oh, I went too far. Let's check our work by plugging in something between -1 and -5/18. Let's pick -1/2, since that's right in between there, and probably the easiest fraction I can think of. So 18 multiplied by -1/2 squared plus 23 multiplied by -1/2 plus 5. That's all got to be less than or equal to 0. Well, when we square -1/2, we get +1/4. +1/4 times 18 is 4.5. 23 multiplied by -1/2. Well, half of 23 would be 11.5, and it's got to be negative. Then that'll be added with 5, and that's got to be less than or equal to 0. When we combine like terms here, we'll see that -2 is less than or equal to 0. That is true, meaning where we really put our shading is in between those points. Ultimately, what that says is that x, oh, and by the way, my apologies, as I shade, I also need filled in circles because it is less than or equal to those boundary points. So we have filled in circles and shading, meaning that x is less than or equal to -5/18, but also x is greater than or equal to -1. We also have a third way we can write these now. You've seen this set notation. We use a bracket because it's got the inequality and equal to, so it's equal to the boundary points. Our left boundary, or the smallest we can be, is -1. And then the largest we can be is -5/18. So we've written that answer 3 different ways that are all acceptable, and we've solved that quadratic inequality. We'll do one more from this worksheet just to help out those of you who might still be struggling a little bit, and then I think we should be in pretty good shape. So if we look at the next one, well, let's jump down to number 3. Number 3 is -9x squared plus 29x minus 6, and that is greater than or equal to 0. Let me get my problem a little lined up. So again, -9x squared. All right, we look at this, and I think some of you might be tempted to try the alternative methods like completing the square of the quadratic formula. There's certainly no problem with those methods. Those methods are excellent because they both can always work for us. But you have to remember, if you want to complete the square, this value here needs to be a 1 in front of x squared before we get started. So you'll have to divide everything in this whole equation by -9. So no matter what, even if it doesn't go into 29 or -6 evenly, you have to make that into a 1 and divide the entire equation by negative 9. Because of that, I wouldn't recommend doing that. I would always try factoring first to see if it actually works out with factors. So we get our rectangle going, our diamond problem. You'll see negative x squared in one, or 9x squared in one corner, negative 6 in another, which gives us positive 54x squared when we multiply. Then we have to add to 29x. Well, I know two factors of 54 are 27 and 2. And those definitely add to 29, so I put 27x and 2x to get that 54x squared, and then add to 29x. So we fill those in our rectangle, pull out our greatest common factors from each. So I'll pull down from 27x and negative 9x squared. I can take out the 9 and the x. Let's also make that negative, meaning we pulled out a factor of negative 9x. What that does is that means this can be a positive x, but then to get positive 27, we have to use positive 3 here. 3 times negative 9 is, got to use negative 3, is positive 27. Now, what multiplies with negative 3 to get negative 6? Well, that's 2. Unfortunately, 2 times x is 2x. So we have our factors. We're going to replace our sum with the product of the two factors. So x minus 3 multiplied by negative 9x plus 2. That's greater than or equal to 0. Let's just call it equal to 0 as we get our boundary points so that we can set up the zero product property again. Oop, I don't know why I had parentheses on the brain there. When we solve these, we'll see that x is equal to 3, or also x could be equal to positive 2/9. We have our boundary points, just like before. Let's put them on a number line so we can easily see those regions we want to test. So if 0 is right here, well, 2/9 is smaller than 3, so let's put 2 over 9 here, and then 3 out here. Same thing as before, we have regions less than 2/9, greater than 2/9 but less than 3, or greater than 3 that could all work. So those will be the areas we test. If we erase things, so we have a little room to work, I always like to start testing my easy point. I don't know why, call me a lazy math teacher, but I want to start by testing with 0, which would be less than 2/9. So let's do that. Negative 9 times 0 squared plus 29 multiplied by 0 minus 6 is greater than or equal to 0. Well, those cancel out, and we get negative 6 is greater than or equal to 0. That's not true, meaning we won't be shading here. All right. At this point, we've seen that anytime we do this, it ends up being in between our boundary points if it doesn't work outside of one of them. So just keep that in mind as we test. We'll test greater than 3 just to see. Let's pick 4 to test it out. So I have negative 9 multiplied by 4 squared plus 29 multiplied by 4 minus 6 is greater than or equal to 0. 4 squared is 16, so we'll do negative 9 times 16 plus 29 times 4 minus 6 is greater than or equal to 0. Well, negative 9 times 16 is negative 144. We add that with 29 times 4, which gives us 80 and 30, 116 minus 6. Boy, I hope I'm right on those. Double check my multiplication, but I believe I did it right. So now, negative 144 plus, let's turn that into 110 by combining those to make the math a little easier. I can tell right away this is going to be a negative value, which won't be greater than or equal to 0. It's actually negative 34. Not true. So this won't be correct either. We're down to just that one region where our solutions could be. Let's pick a value in there. Let's pick 1 since it's in between there and will be relatively easy. So negative 9 times 1 squared is actually just negative 9 times 1 plus 29 times 1, which is 29, minus 6 is greater than or equal to 0. Well, this certainly looks like it's going to be positive. When we combine like terms, you should see 14 is greater than or equal to 0. That's true. Because it's greater than or equal, we use filled in circles on those points and then shade in between. Remember our other ways to write the answer. So x could be greater than or equal to 2 over 9. X is also less than or equal to 3. Finally, that set notation, the smallest we could be is 2 over 9, and I've used a bracket since it could equal 2 over 9. The greatest we could be is 3. 3 different ways to write that solution set. All of those are acceptable, and hopefully this helped you out if you had any issues with yesterday's worksheet. There isn't going to be a new worksheet today, so please revisit the work you've done with quadratic inequalities. We're actually headed towards a quiz early next week, so now's your day to really check and see if you've been doing things correctly. I have office hours today as usual, so please let me know if you have any questions. All right, thank you guys.